Distance, find the distance from me to that person as a function of theta. In other words, I give you the angle, you give me the distance. Make sense? Like if I tell you this is 20 degrees, you should be able to tell me how far away we are. Yes? Okay, so what do we know? Well, I can do this, right? Do you all see this triangle? Let's see. Well, I'll do it this way. Let's do this triangle. Do y'all see that? That's basically me drawing like that, right? There's theta, and then this is 40, that's 40. Yes? Y'all agree with that? Okay, and I'm interested in the distance between myself and that person. Let's call it D, right there. Yeah, it's the hypotenuse, right? Now, I'm supposed to give you the distance between us as a function of theta. So what I'd like to do is use some sort of trig function that connects those things together. So what trig function would connect theta, 40, and the hypotenuse together? Cosine or sine or tangent? Theta, this is the opposite, right? And this is the hypotenuse. Opposite and hypotenuse is sine, right? So you could write this. Sine of theta equals 40 over d. You with me? Now I want the distance as a function of theta. So let me solve for d. I'm going to multiply both sides by d here. D sine of theta equals 40, right? Now get d by itself. I'm going to divide both sides by sine theta. D is equal to 40 over sine theta. You know, still there? Just divide both sides by sine theta. But isn't this the same as d equals 40 times cosecant theta? Isn't dividing by sine theta the same as multiplying by cosecant? Is that the same? Yes? Do I have the distance as a function of theta? You give me theta, I give you the distance. Okay. So what if I tell you right now that the angle is 0? How far away are they?
40 feet.
This is the angle from here to here. If I tell you the angle is 0, how far away are they? They're not allowed to come across. They have to stay on that side. Is it possible? It's not possible, is it? Do y'all see that? It's not possible. Because if the angle is 0, right, then this blue line is down straight like this, but then that means they've come across. They have to stay on this side, right? This has to always be 40. So do y'all see that this function would be undefined at 0? Right? It's undefined at 0. So if I were to think about what the graph of that would look like, at 0, it's undefined, right? Where else would it be 0? Where else would it be undefined? Well, here it's 90 degrees, right? Pi over 2, but wouldn't we also have a problem at pi? So it would also be undefined at pi. Yeah? What would it be at pi over 2? What would the distance between us be? 40. So at pi over 2, it's, let's say that's 40. We're at 40, right? Yeah? What if I tell you that this angle right here is really small? Like what if I say that's like 1 degree? 1 degree. That person is really far away from me, aren't they? Really, really far. So if I have a very small angle, the person should be really far. So this is going to look like this, isn't it? And this side, same thing. If I go over here and I make my angle really, really close to pi, that means they're really, really far away. Do y'all see that this graph is a perfect representation of this physical situation? Yeah? It's a cosecant function. It's a useful function. So, you know, in calculus, what we would say in a calculus class is this. We would say this person is running at 20 feet per second. And I want to know when they're a certain distance down, I want to know how fast this angle is changing. That's a much more difficult question, but that would be a calculus question. It's like, we call those related rate problems. But in order to do a problem like that in calculus, you have to understand how this geometry turns into this trig function, and this trig function looks like this, and this is a perfect representation of what's happening. Okay? I hope that helps you kind of see like where we would maybe use some of this, right? Somewhere. All right, let's see. How are we doing? I have a little bit of time. I don't know if we should do this. I can start it at least. So one thing I've conveniently avoided so far is this thing called phase shift. I've stayed away from it, but we're gonna talk about it right now. So let's talk about the most general form of sine and cosine. So sine and cosine are like the fundamental functions for trig functions. Those are like the fundamental ones, sine and cosine. From sine and cosine, you can build all the others. You can build tangent, cotangent, secant, cosecant, all from those two. So we've looked at like different things, different adaptations of sine and cosine, but the most general way you could see a sine function would be y equals some number a, which would turn out to give you your amplitude, sine, and I want to follow the book's format here, because in different textbooks we use different letters. Then they put a some number in front of x, omega x minus, that's, anyone know what that Greek letter is? No? Yeah?
I have a picture of my tutoring.
Yeah, this is called phi or phi. It's pronounced, people pronounce, there's like a big argument about how you pronounce this, okay? Phi or phi, all right? I don't care which way you say it. This is omega, okay? We use Greek letters in math just to make people like make their brains hurt, okay? Sine a we could have done a, b, and c if we wanted, but we put omega here for the number in front of x. We put phi or phi here, minus phi or phi, and then finally plus out here, and I don't know why we do this, but we're going to put b out here, capital B, all right? That is the most general way you could see a sine function. Let me give you a specific example next to this. Y equals negative 5 sine of 2x minus pi plus 3. There we go. Pardon me? Just B? Yeah. This is A and this is B. Yeah, no, these aren't Greek letters. These are Greek letters. By the way, my phi is technically, people draw it different ways. My phi almost looks like, I will admit this, my phi almost looks like the empty set. It's not the empty set, so I'm telling you that someone could confuse that with this symbol for empty set. I'm telling you that's not the empty set, that's phi, all right? We haven't really talked too much about the empty set anyway, so we don't need to worry about it. But all right, so do y'all see, I mean, we've kind of done this already a little bit, right? We've done all this. I've asked you to graph something like this before. All right, but now we have names for this. In this problem here, A would be negative 5, right? Not the amplitude, but if we're just matching it with what's over here. A is negative 5. Omega is what? 2. And let's see, phi is, be careful here, pi, right? Notice in the formula, it's minus phi, right? So if we have minus pi, then phi is pi. What if this was plus pi? What would this be? Negative pi, right? So it's always the opposite of what you see there. And then what would our b be? What would our b be? 3, okay? So why is this useful? Because if you can identify A, omega, phi, and b, then you can calculate pretty much everything you need in terms of like the things that happen to the graph. The amplitude, right? The amplitude of this graph will be the absolute value of phi. I should put it over here. The amplitude of this will be the absolute value of A, right? That's what we can get. The period, all right? The period will always be, and we actually have a name for period, or a letter for it. We call it capital T. That's what the period is, all right? Don't ask me, all right? It's 2 pi divided by omega. There's a formula for it. So looking at this, well, we'll do it over there in a minute. That's the period. And then you have what's called the phase shift. Now we have not talked about phase shift, but that's why I want to bring this up. The phase shift is basically going to measure, it's like you take the original sine function, and we're doing things like stretching it, compressing it, flipping it, and then we're moving it left or moving it right. And that's called your phase shift. It's just your left-right movement. And that can be calculated by taking your phi and dividing it by your omega. So come over here and tell me what the period of this is. What's the period of this particular sine function? It would be 2 pi over what? 2, which would just be pi, okay? So that's the period of this if I graph it. Now, what is the phase shift? I'm just going to put PS. We don't have a letter for phase shift. So I'm just going to put PS for phase shift. What would that be? According to the formula, it would be what? Pi over 2. It would be the omega divided by the phi divided by the omega. So pi divided by 2. All right, so this is like a sine function that has an amplitude of 5, a period of pi. The phase shift has been moved, pi over 2, and the whole thing's been flipped over, but we didn't mention that yet, all right? If I asked you to graph this, though, how would you graph this? The same way we've been doing it. You do the 5 points, right? You set the argument equal to the 5 points. You would do your 5 points, you draw your picture, flip it if you need to, and then remember this number out here would mean that whatever you finish with your picture, you just need to move the whole thing up 3 units. All right? The phase shift is already taken care of. You don't have to worry about this. When you set that equal to the 5 different points, that will take care of your phase shift for you. The only thing you have to really worry about is the flipping and the up or down with this number. All right, I wanted to save 20 minutes. In terms of homework, really, you need to really just be worried about getting ready for this test, right, on Thursday. So focus on that, right? And we will, when we finish the test, we'll start talking about where we go from here, what homework in Chapter 7 we even need to worry about. I'm ready to get into the next chapter. I really am ready to move on. Test, what do you want to discuss? Anything off the review that you need clarification on? Anything that didn't make sense? Want to see another example like something? Anything? Y'all are ready, huh? Should we look at it? Has everyone had a chance to look at the review? I hope you have. That's why I sent it out last week? Yeah? When did I send that out? Friday, right? I was sick, and I was sitting there doing the review. And then the next morning, I think I woke up and did the solutions. Question, yes? No, go ahead. You were first. Yep.
Were we going to have a reference sheet again?
I'm glad you brought that up. So I think I said on here, right, on the review, that you'll need to know the unit circle. I'll provide you one, right? I'll provide you one. I've been thinking a lot about this, and I keep going back and forth. So why don't we just settle this as a class, all right? Here's what I'd like to do. I'd like to allow you to have a reference sheet, okay? Where you can put down formulas. Shit, if you need the unit circle, you can draw the unit circle, okay? You just can't have any worked out problems. Understood? I'd like to do that. But to me, I think that it has to come with a cost. In other words, I think the only way that you can get 100 on this test is if you don't have a reference sheet. In other words, if you want to use a reference sheet, you have to pay with points. So if you feel like you need it, then you can use it, but it's going to cost you. The thing I haven't figured out is how many points. 2 points. 2 points. Okay, but what about the student who's at the level where they don't need that guide? What separates them from the student who does? Do you see what I'm getting at? Right? Like, to me, an A student is a student that would be ready for this test who doesn't need a unit circle. That what they would need is they get the test and they could just do a quick sketch of the unit circle just right there. If they needed it, they could do it by, right? You've all done that for me at least once, right? You've all drawn me the unit circle before. So to me, that's like an A student, a student who's at that point where that reference is not necessary. But at the same time, I understand that some students aren't there yet, so I want to be able to offer that. So 2 points, what do y'all think is fair? I don't think 2 points is fair. 1? 1 point, yeah. You think a whole letter grade's too much? 5 points? Okay, I'll flip it around. Why don't we do it the other way? How about if you don't use one, you start with a 10-point curve in your favor?
Oh, that's better. That's a lot better than taking
Right? That way, everybody could do an A on the test. But those people who get higher, that'll cushion them for later, right? Their average in the class could be higher. What do y'all think of that?
I like that.
Okay, so you have to make a decision. If you don't want a reference sheet, then you start out with a 10-point plus. If you use a reference sheet, then the highest you can get, is 100, but, So that's the other extreme. So what do y'all think? You like the second option? Of course y'all do. Yeah. You feel like you're at a car dealership? Well, let me ask you this. When you get to the problems like numbers, where are they? When I'm asking you for exact answers, where are those problems? Those, 9 through 16. I don't want people on their calculators cranking those out. Like, those are not calculator problems. So how am I supposed to do that? Right? So maybe we start the test and there's one set of questions that you do with no calculator, and then once you turn it in, then you can use your calculator.
So, like taking the test in parts?
Yeah, like you come in, you sit down, and I say, okay, the first page of the test is you cannot use your calculator. And then you do that, and then once you're done, you turn it in, and then the rest of the test you can use your calculator. Let's plan on that. Okay? It'll be a short thing just like that, where you just, the whole idea behind this, questions 9 through 12, is that you're counting your way around the unit circle, either clockwise or counterclockwise. Notice all of those angles, 11 pi over 6, 13 pi over 4, they're all a multiple of one of the common angles you should know. So you should just be able to count your way around and then figure out either x or y coordinate, depending on whether or not it's asking for sine, cosine, secant, cosecant.
By the way,
Yeah.
for the solutions, you didn't do the last 3 problems.
I didn't do the last 3.
At least when I went.
Let me see. Well, okay, I didn't do 26, right? I didn't do 26 and 27 because I knew I was going to do those in class today, right? So not those, but I graphed a tangent today, didn't I? And I graphed a cotangent. So I feel like y'all should be able to do those. And number 28, I did not do. Yeah. So, yeah. Uh-huh.
Like our printout reference sheets, can we use that, like, not be counted as a reference sheet? Or,
Do what?
like, you were saying if we use a reference sheet that we write, then we will lose those additional 10 points. But are we allowed to use, like, the printout reference sheets that we have?
What we have on the website that you can print, that won't cost you anything. All right. So, yes.
Can we go over number 10, please?
Number 10, yeah. Let's finish up. Let's establish the rules. Let's just finalize the rules. Okay? I think the good middle ground of this is this. Inside my heart, I feel like it should cost you 10 points to have a reference sheet. That's the way I feel. All right? And then there's that real good part of me that's like, wait, hold on. Let's do it the other way where it's like you get plus 10 if you don't use one. So I'm going to meet in the middle. If you don't use one, 95 is the highest score you can get on the test. If you use one, the highest you can get is a 95. If you don't use one, you get a 5-point bonus to start the test. That's I think is a fair middle ground. Does everyone understand that? It's that reference sheet. You can it can be a unit circle where you draw a bunch of other stuff on there too. No worked out problems, no worked out, no examples, just formulas, steps, procedures. You can draw. I don't mind if on that reference sheet you draw a basic sine function and you put, the period. All that stuff is okay with me. That's not really an example. Those are properties of the trig functions. You can use the formula sheets for the entire test. Okay, entire test you can have your reference sheet and formula sheets. But there will be a part of the test in the beginning where you will use a calculator, right? If you want, you can do it backwards, where you start with your calculator and you save the calculator part for the end. I don't care. You can do it either way. Does that make sense to you? At some point, you'll have to put your calculator away and do a separate sheet. All right? We're good? We understand what's going to happen at the test? Yes?
Yes, I was just going to ask, is it going to be similar, like, as far as how many questions our first exam, like, kind of around that range?
I can't say how many questions because they're different type of problems, right? They're different lengths. I haven't made the test, so I can't tell you. The review is obviously, I think, a little bit longer than the true test would be. I think I may have said that, yeah. So I don't know yet. I'll probably make the test tomorrow night. All right, I'm being asked for number 10. Number 10, cosecant of 13 pi over 4. So this is the way I feel like a problem like this should be done. All right, I'm going to tell you how I feel like this should be done. This, you first just realize this is 1 over sine of 13 pi over 4. That's just the definition of what cosecant is, right? And then I just got to figure out what's sine of 13 pi over 4. Well, 13 pi over 4, sine is the y coordinate on the unit circle, right? On the unit circle, sine is always the y coordinate, cosine is the x coordinate. So I just need to go to the unit circle. I need to go to this angle and pop off the y coordinate. right? Okay, so I need to go to 13 pi over 4. Well, I know that pi over 4s are these angles, right? Those are my pi over 4s. So I need 13 of them. So I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's where I am. I counted that way because it's a positive angle. Had that been a negative angle, I would have counted this way 13. So here's where I am, and I need to know the y coordinate there, which I know is what? Negative root 2 over 2? So this is going to be 1 over negative root 2 over 2. And then 1 divided by a fraction is the same as the reciprocal, so I'm just going to flip it over. Doesn't matter where I put the negative. I can put it out front, on the top, bottom, or out front. There we go. Is that what I had there? Yeah. Does that make sense? Would you like to see another one of those done? Or, yeah, which one? Or do you want me to make up another one? You want to make another one up? How about, do we have a cotangent there? We do have a cotangent. Yeah, okay. Pi over 4, pi over 3s. I have everything almost, right?
Is it okay if we leave the root at the bottom? Or did you want
Yes. Do you remember we had that conversation about how back in the old days, remember that?
Yeah.
Yeah, so yeah, leave it. That's fine. Now, if you want to, you can rationalize if you want to, but I won't take off if you leave it like that. I'm just going to make one up. What if we wanted cosine of negative 30 pi over 6? So this is going to kind of suck, all right? Because I'm going to be counting by pi over 6s, and I'm going to be counting 30 of them. And I'm going to be going clockwise because my angle is negative. And then I'm going to be looking for the x-coordinate once I land where I need to land. So I need to know what pi over 6s look like. Those are where we're cutting each quadrant into 3 equal pieces. Right? So I'm basically drawing this unit circle without the 45s in there, right? It's just the 30, 60, 90. And each one of these is a pi over 6, right? Each one of those is 1 pi over 6. And I'm going to count 30 of them, but going this way. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20, 21. Is that where I am? That doesn't seem right. Oh yeah, that's 5. That's where I am. I could change that to any number. Okay, the idea is that you count. I shouldn't have put 30 because 30 divided by 6 is 5. Okay, so I would have been at negative 5 pi. That was too easy. Let's go negative 31. That puts me here. Understand? Negative 31. So, and I'm looking for which coordinate here? X coordinate because it's cosine. What's the x coordinate there? Negative root 3 over 2. Right? Is that helping or no? Yeah. Yes? Now what about the ones with the angles that are in degrees? Those are a little different because you don't really count as easily that way. Well, maybe you do. Like what about that one, number 14, where it's tangent of 495? So for that, if I were doing this problem, what I would do is probably subtract 360 from this. And if I subtract 360, I get 1, not 5, sorry, 5, not 1. And then here I get 3, and then 135 degrees, right? And so I know where that is because that's one of our common angles, right? This is 90, 45, 90. What's this one? 135 right here, right? That's 135 degrees. And tangent is what? Y over x. And since at that point, the y and the x are the same, but one of them's negative, the other one's positive. So this should just be negative 1. Okay? Anything else? Yes?
Can you do the last one? I know, like I have some notes on the last one. It was like 26.
Yeah, I can't believe nobody's asking me about the solving these. Y'all are okay with those? Solving, getting those solutions? Find all the solutions to that equation? Y'all are okay with those? Yeah, we talked about it today, right? What?
Is it just this, that 9 through 16 that you said we weren't going to have a calculator?
Yeah, those are the ones without the calculator.
So everything else?
Everything else you'd be able to use a calculator.
Can we do one of those?
You want to do, what else? Didn't you ask about something else though?
It was like the very last question.
The sketching?
28.
Oh, that one. Yeah, we can talk about it.
No, it's fine. I just wanted to go over it because it's been a while.
Yeah, we can talk about that, but let me do one of those other ones first. How about this? This is actually, I'm going to make one up here. So how about this? How about sine squared x minus 1 equals 0? I want to solve for all values of x which make this equation true. Solve, give me all the solutions of that equation. Now, this notation here, I showed y'all at least once in class that what that notation means is sine x squared. It's just a notation. It's actually a shitty notation. I wish we didn't use that notation, but that's what we use, all right? So what do you think? A couple of ways to do this. I'm going to move first. This is the way I'm going to do it first. I'm going to move the 1 over, all right? So now I'm saying, hey, look, sine, I'm going to write it the other way. Sine of x squared equals 1. Agreed? Now I'm going to take the square root on both sides. And when I take square root on the left, the square root goes away, right? When I take square root on the right, I have to do plus or minus. Because anytime you take the square root of something, you have to do plus or minus. So the left side now becomes sine x, and the right side becomes plus or minus what? Square root of 1, which is just 1. So this is really saying, where is sine x equal to 1, and where is sine x equal to negative 1? Right? That's what that's really saying. Go back to your unit circle. Sine is which coordinate? The y coordinate. So that's really saying, where's the y coordinate 1, and where's the y coordinate negative 1? All answers that land here are here. So x would be what? Pi over 2 plus pi k. So you're going to start here at pi over 2 and then start jumping half rotations, either direction.